Motion is the action of changing location or position from the moving away of all heavenly bodies from the origin, or what we now call as expansion of the universe, to every life on earth where there is blood running in our arteries, veins, and capillaries caused by the pumping of the heart, to the very DNA, the carrier of our genetic information, that is moving to self-replicate and down to atom, the basic unit of a chemical element, that its microscopic components continuously orbiting its nucleus. All of these are motion.
Okay. Ako naman to. The first evidence of the study of the motion of heavenly bodies can be traced back to the people of Sumeria and Egypt. While the Greeks were the first ones to study systematically and in detail the heavenly bodies, they regarded the Earth as the center of the universe, geocentric. This idea of geocentric Earth was replaced by the heliocentric model of Nicolaus Copernicus, where Earth and other planets revolve in circular orbits around the Sun. Eh. These early studies were the foundations of Galileo Galilei, an Italian physicist, to revolutionize science. Let us play. Okay. Uh, are you familiar with the words? Tell me, which one are you familiar with?
Vacuum.
What is a vacuum?
It is an empty space.
An empty space. Okay. What else?
There is no sound can travel because it's nothing. There's no air, no fluid.
Yeah, that's interesting. No sound can travel in vacuum, right?
Yes.
Why?
Because there's no medium for the sound waves to bounce.
Okay, great. That's correct. What else?
Uh, the impetus.
What is impetus?
It is the cause of force or motion of an object.
Okay. What else?
Acceleration.
What is acceleration?
It is the rate of the change of speed or velocity of an
Okay.
object over time.
Okay. What else?
Cannonball.
Cannonball.
Yes. It is a round object fired from a cannon or by
Yes.
a cannon. The parabola.
Parabola. What do you mean by
Yes.
parabola?
It is like a semicircle.
Semicircle. Okay. Now let us see. Can you please read?
The
Impetus.
force or energy with which a body moves.
Okay, you're
Impetus.
right. Next.
Acceleration, the rate of change of velocity per unit of time.
Don't forget those definition. Cannonball, please.
A
See.
round metal or stone projectile fired from a cannon in former times.
Okay, so yun ang panggera nila. Cannonball are their weapons, no? The powerful weapon during that time. Okay. Vacuum.
A space entirely devoid of matter.
A space entirely devoid of matter. No matters there. Everything. So there is no medium for the sound to travel. Now my question is, which place is a vacuum?
Outer space.
Yes. Okay. Outer space is a vacuum. How about, can we produce a vacuum here on Earth?
Yes.
Yes, of course. Yeah, scientists can simulate vacuum, no? We can also simulate vacuum in our own way. How's that? How can we simulate in our own way that we can have a vacuum? So let us say we have the bottle, okay? We have the bottle. We put a candle inside of that bottle, and then we light up the candle. So the bottle with a candle, with the candle light, we cover it with the cup. What will happen? We secure it with the cup. What will happen to the light of the candle?
it will be gone.
Yes, the light of the candle will be extinguished. Why?
Yes. Yes. There's no
Why?
oxygen.
Yes, there is no oxygen, and therefore the bottle, the inside of the bottle is what?
Vacuum.
A vacuum now. The inside
Mhm.
of the bottle is vacuum now. So we can simulate vacuum on Earth. But the infinite vacuum is outside of our atmosphere. Okay? Next.
A property of matter by which it continues in its existing state of rest or uniform motion in a straight line, unless that state is changed by an external force.
Inertia. Did you understand what you're reading? Can you please give me an example?
Yes, when we're in a car and it's not moving, and then suddenly it starts to move, we will be like the passengers will be thrown back.
Okay, that is a classic example of inertia, no?
Yes.
A body at rest will remain at rest even when a force is applied, no? Okay,
Mm-hmm.
ayun ang inertia. What else?
Mm,
How about if you are moving and then the car suddenly stops? What would
yeah.
happen?
The passengers will be thrown forward.
That is inertia, no?
Inertia, inertia.
A body in motion will remain in motion even if acted upon by the force. So the continuity, that is the inertia. The continuity after a force is applied. Okay? That is
Yeah.
the continuity after the force is applied. No? This is different from momentum. No? Another computation naman yun. What's this? Projectile.
An object propelled through the air, especially one thrown as a weapon.
How about this one?
An influence tending to change the motion of a body or produce motion or stress in a stationary body.
Next.
A symmetrical open plane curve formed by the intersection of a cone with a plane parallel to its side.
We'll be going to talk Aristotle concept of vertical motion, horizontal motion, and projectile motion. Can you please read?
Vertical motion is referred to as natural motion. In a natural motion, the object will move and will return to its natural state based on the object's material or composition: earth, water, air, and fire.
Continue reading.
Aristotelian concept of natural motion is largely vertical motion, which is falling or rising.
Aha! Aristotelian concept, natural motion is vertical motion. Natural motion is vertical motion. Means up and down. That is the natural motion according to Aristotle. Okay? Aristotle believed that because a ball fell when thrown upward, its element was earth. Ah, okay. So, this is Aristotle's concept, vertical motion. Because the ball fell means that the element of that ball was earth. How about this one?
Smoke goes up there because it seeks its natural place in the atmosphere.
An object moving in a violent motion requires push or pull to maintain a horizontal motion. Motion continues only so long as there is an applied force to an object. When the force is removed, motion stops. Can you please read the other paragraph, please?
Aristotle classified any motion that required a force as a violent motion. He did not mean violent in the sense that it is marked by the use of harmful or destructive physical force.
Now let us see this one. The example at the right shows a box of documents. The box will remain on the floor unless a push or a pull force is applied. Now let us see. Okay? The box is being pushed. Then the box is being pulled. Okay. Next. Can you please read?
Aristotle believed that the projectile motion of an object is parallel to the ground until it is the object's time to fall back into the ground. An impetus will be kept by the object until such time that the initial force is forgotten, and the object returns to its natural state to stop moving and fell to the ground.
Can you please explain?
Uh, the object, if it's drawn, the object will move in a straight line, and then when it stops, when it's time to stop moving, it will directly fall to the ground.
Okay. Let us see if you're right. Okay. What's that? What are you seeing?
Canon.
A cannon pointed upward, huh?
Yes.
Okay. According to Aristotle, what happened? So a
It,
cannon is being fired,
yes.
and then it stops at that point. A cannonball. You know. Initial force is forgotten, and the object returns to its natural state to stop moving. That is according to Aristotle. And then what will happen as per Aristotle?
It will drop directly to the ground.
Okay. That is the concept of Aristotle about the projectile motion. And what else? According to him, the movement of the cannonball is parallel to the ground. Imagine the movement of the cannonball is parallel to the ground, and later on, when the initial force is forgotten, it will suddenly stop and fall straight. So we can draw a line just like L, no? L, parallel to the ground and then directly fall like this. That is the concept of Aristotle about the projectile motion. Let us see the cannon, the projectile is not pointing upward like that one. Okay, again, this is the concept. The same, huh? The same. Whether the projectile is pointed upward or not, unless you point that projectile downward. Huh? Okay, movement of the cannonball is parallel to the ground. Okay, how about this one? Can you please read?
Aristotle viewed projectile motion as natural and violent motion. He said that heavy objects fall faster than light ones.
Don't forget that is what Aristotle's concept of projectile motion. Projectile motion, Aristotle viewed projectile motion as natural. Projectile motion as natural and violent. No? Heavy objects fall faster than light ones. Okay. So do you agree? Or
Dep-
depend?
Depends.
Depends. Or yes?
Uh,
Uh, why yes?
no, actually, it depends on the size.
Depends on the size. Yes, possible. Yes. A heavy object, no?
Uh,
Depends on the size. Can you please further explain?
um, uh, maybe that the density of the object, because it may be
Actually, the
big,
mass,
but
the weight.
yes. Yes.
Heavy object.
Yeah. Heavy object, and it's very small.
Very small. Yes. Heavy object, very small.
Yeah.
Yes.
It will drop very fast to the ground. Compared
Uh, yes. Go ahead.
compared to a heavy object that is large. That is
Mm-hmm.
very big. The smaller one will drop faster
Why?
because it's smaller. It has less air, area of resistance.
Okay, great. A notorious problem for the Aristotelian view was why arrows shot from a bow continued to fly through the air after they had left the bow, and the string was no longer applying force to them. What do you mean by notorious?
Well known, famous.
Yes. So that is a well-known problem for Aristotelian view about the arrow shot from above. Okay, let us see. This is a force, a manual force coming from a human. Huh? Okay, see, go straight up with force. It's supposed to die down. No, why? Why it continues that way? The arrow. Okay, see. Now let us see. This is the explanation of Aristotle. Initial motive force transferred to the medium initially surrounding the object, a power to act as motive force. Yeah. See, that's impetus. So that's the motive force feeding the uh, the arrow to continue moving ahead. Okay. Medium then forces object into new region, which is then imparted with the power to act like this. Airflow, so the airflow sustain the movement of the arrow. Can you please read?
In the absence of a resistance, objects would fall not depending on their weight but in the time of fall. Also, if the object encountered a resistive force from a fluid equal or greater than its weight, it will slow down and reaches a uniform motion until it reaches the bottom and stops.
Okay. What do you mean by in the absence of resistance? Absence of resistance. What is this?
There is no resistance. It is ignored.
Yeah. If there is absence of resistance, what do you call
Oh,
that a region? What do you call that space? If there is an absence of resistance.
mm, it's a vacuum.
Yes, it's a vacuum. There is no resistance. There is no matter. There is no matter that will resist something, no? That will counter, uh, that will hinder, no? Absence of a resistance. This is a vacuum. Objects would fall not depending on their weight, but in the time of fall, no? Example in the outer space on moon. Uh, an astronaut drop a feather and a stone. Both of them will slowly go down, no? In equal time. Not because one is heavy, not because one is light. Because there is an absence of a resistance, a vacuum, a space. That's why we will not be going to talk about the weight, how many kilogram. No, we will not be going to talk about that. In the absence of resistance, we will be going to talk of time. That the length of time it will fall. Okay, because weight is immaterial in vacuum. Okay, understand? That is Galileo's concept. Also, if the object encountered a resistive force from a fluid equal or greater than its weight, no, it will slow down. A fluid is not necessarily a liquid. Remember that, huh? A fluid is not necessarily a liquid. It can also be air, no? Can also be air. Anything that easily to be moved. Okay. So if there is a resistance greater than the weight of the object, the movement of that object will slow down. Greater or equal, no? The movement of that object will slow down. Okay. Next, let us see. Can you please read?
Without any resistance, a 30-gram object will be as fast as a 600-gram object when falling because they fall with the same amount of time, given that they are released from the same height. Also, a stone dropped in the ocean will sooner or later travel at constant speed.
That was what I'm talking a minute ago about that. That the weight is immaterial when we are talking of vacuum. However, this is not possible on Earth, no, because Earth is not a vacuum, no. Earth is full of matter, anywhere, everywhere. Okay. Now let us see when I will be going to drop a stone, 30-gram object and a 30-gram stone. Let us see. Stone 30-gram, 600-gram, free fall throwing. Okay. Mm-hmm. Okay. This is interesting. Have you seen? Let us
Yes.
let us review. No. Let us review. Okay. Mhm. Please watch carefully. Uh-huh. Have you seen that? Slow motion this time. What happened? What happened?
Smaller one is the smaller one is faster.
The smaller one is faster. Why do you think so?
Uh, it has less wind resistance.
But have you noticed when the two stones is nearing was nearing the ground,
Yes.
what happened?
They both hit the ground at the same time.
Okay, so we will discuss that in our next lesson. So this is another topic to be discussed because it will take long. This is very interesting also. What we are now going to discuss is about Aristotle concept and Galileo's concept of vertical, horizontal, and projectile motion. We will dig deeper into that in our next topic. Meanwhile, we concentrate on this. Okay. Can you please read? Okay.
Um,
That's interesting to learn, huh? That falling, huh? That free fall. Okay. Can you please read?
an object in motion, if unimpeded, will continue to be in motion, and an external force is not necessary to maintain the motion.
Okay. An object in motion, if unimpeded, we are talking of vacuum. Because in vacuum, there is no resistance. Nothing will impede you. Okay. So this is the outer space in general. Outer space is very big, infinite. Let's say you throw an object. So you're the Superman. You will be going to throw the car outside of the earth. What will happen to the car you thrown when it exited the atmosphere?
It will travel in a straight line, and it will be in the constant. It will have a constant speed and direction.
Yes, constant speed and direction for the rest of that car's life or in perpetuity, no, up to infinity. Once you get out of the Earth's atmosphere, the space now is vacuum. If your speed when you ejected out of Earth is 100 kilometers per hour, when you ejected out of the Earth's atmosphere, and then you enter the vacuum, for the rest of your life, the speed will remain 100 kilometers per hour in one direction, in that straight line, forever to infinity. Why? Because that is already inertia when you thrown out, and that inertia will continue to vacuum. You're in the vacuum space, so that inertia will continue unless acted upon by a force. Say a small object during its course of voyage to the infinity, and then an object hit the car, it could reduce or further further increase the speed of the car, no? It's inertia because another object hit the car depending on which position the car is being hit, and the direction can be affected, no? Can change, no? Understand?
Yes.
See, if you're in vacuum, once you've been thrown out from Earth, if your initial speed when you leave the Earth is 100 kilometers per hour, that will be your uh, speed for the rest of your life, unless acted upon by any force. Okay? Speed and direction will continue in perpetuity in that direction. Very clear? Huh? Very clear?
Yes.
Just like this a Voyager. No? Tong Voyager na to, na nilaunch pa noong 1977. Tong, ayan no, yung Voyager na yan no. Voyager spacecraft, naka-exit na ngayon yan sa helipose. Nasa new space na siya, the interstellar space. Yung movement niya, in perpetuity na yan. Kung anong speed niyan, forever na yung speed niya. Yan. Kung nako-control pa yan sa NASA, okay pa. Pero kung hindi sa kinokontrol, yung speed niya, kung ano yung speed niya, pa the rest of the Voyager's life, ayun lang ang speed niya at ayun lang ang direction niya, tatahakin niya. Maliban lang kung i-maneuver yan ng ground station sa NASA. Understand? Ha?
Yes.
Great. Now, kami. Horizontal motion. Can you please read?
If Earth's surface is very smooth, flat, and extended infinitely, objects that are pushed will continue to move unimpeded for the rest of the object's life or in perpetuity. However, this kind of motion is not evident in nature.
Okay. So, this is it. Let us say the Earth is a very smooth, flat, no? And extended infinitely. Sabihin mo hindi oblate spheroid ang Earth, no? Sabihin natin napaka-flat niya to infinity, no? At tapos nasa vacuum yung Earth kasi unimpeded, walang mga distraction, walang mga resistance force, walang mga bako-bako, whatever. No smooth flat yan, smooth flat. Or when you throw an object, let's say ball, when you throw a ball, the ball will continue to roll for the rest of the ball's life to infinity. In that speed, say you throw the ball in, let's say, 10 kilometers per hour, the ball will continue 10 kilometers per hour for the rest of the ball's life in perpetuity. No? If the earth is very smooth and flat and extended infinitely, and if earth is vacuum because there is nothing to impede the object, okay? But according to Galileo, however, this kind of motion is not evident in nature, sa atin, sa Earth. Why? Because we are not vacuum. The Earth is not vacuum. Full of atmosphere, full of matter. Okay? For example, if a ball is pushed on the ground on Earth, the ball in many occasions will alter its course along the way due to numerous forces acting on it. The ball will surely slows down, and eventually stops. Okay, ito. This is the example of this. So, this is on Earth. Ha? Alam naman natin na hindi naman tayo vacuum. Maraming hindrance dito. Even the ground, bako-bako, nakaka-apekto yan sa motion, no? Let us witness. Okay. I will be going to throw the ball. Let us see. Okay, the ball is rolling. So changing direction, and now it teaches the grass alter its direction again, and eventually that ball will stop. Okay, so this is it. Because the earth is not a vacuum, there are plenty of resistance. The grass, the rough road, everything, the atmosphere, all those contribute to the stoppage of an object. Okay? Now, those are the impediment. Projectile motion. Can you please read?
One of Galileo's greatest contributions involved accurately measuring the effect of gravity on free-falling bodies. Galileo hypothesized that a falling object would gain equal amounts of velocity in equal amounts of time, which meant that its speed increased at a constant rate as it fell.
So, Galileo, the constant rate as it fell. Galileo's greatest contribution involved accurately measuring the effect of gravity on free-falling bodies. Si Galileo pala una nun. Okay. Next. Can you please read?
As there was no way that could observe his hypothesis about the object's free-falling motion and no technology to record it either, he tried then to decelerate its motion by replacing the falling object with a ball rolling down an inclined plane. Since free falling is essentially equivalent to a completely vertical ramp, he assumed that a ball rolling down a ramp would speed up in the exact same way as a falling ball would.
This is the famous experiment of Galileo when we are talking of the inclined plane, to get this the rate of fall. Because at that time, there was no technology. How can he be able to measure the free-falling object? So he needed an inclined plane so that he can mark the ball, and when it rolls, it leaves a mark on that inclined plane. That was his basis of measuring the acceleration of the ball. So, when we are talking of inclined plane, we can think of Galileo. Now, can you please read?
Using a water clock, Galileo measured the time it took for the ball to roll a known distance down the inclined plane. After many trials, he observed that the amount of time it took for the ball to roll down the entire length of the ramp was equal to double the amount of time it took for the same ball to only roll a quarter of the distance. In other words, if you doubled the amount of time that the ball was rolling, it would travel 4 times as far.
And what Galileo now is talking is the acceleration. Next. Aha, this is the inclined plane of Galileo. We simulate it. Okay, the ball is up there, and we will roll the ball down. Let us see. Okay, see? Slow motion this time. Aha, okay. So that's it. The Galileo's experiment. Now, Galileo was credited for quantifying the rate of fall by measurement of distance and time and plotting it graphically. He was able to slow down the fall using ramps rather than viscous materials as Aristotle did, resulting to significantly different conclusions related to the rate of fall. Okay? Can you please read?
He correctly measured motion into independent directions, horizontal and vertical, and deduced that the rate of fall is better measured in terms of downward acceleration.
He deduced that the rate of fall is better measured in terms of downward acceleration. Downward, speeding up, no? The speed is increasing as it goes down.
Use geometry to provide better description, kinematics of projectile motion, whereby horizontal motion has zero acceleration, constant speed horizontally, and constant vertical acceleration.
Okay, next.
By varying the ball's horizontal velocity and vertical drop, Galileo was able to determine that the path of a projectile is parabolic.
Aha, now parabolic. Compared to Aristotle, no? Parallel to the ground. The path of a projectile is parabolic, no? Mas tama si Galileo kumpara kay sa mga concept ni Aristotle, ha? Okay?
Hmm.
Next.
We believe that a projectile is a combination of uniform motion in the horizontal direction and the uniformly accelerated motion in the vertical direction. If it is not impeded, it will continue to move even without an applied force.
Okay. Very clear. Ayan yung mga paniniwala, concept ni Galileo. Okay. When you shoot a ball in a basketball ring or just even throw away, the ball does not need a force to keep it moving. No? Once you throw it, tapos na. The ball will continue to move until it falls to the ground. Let us see. Okay. Ano yun? Can you please read? Summary of Aristotelian and Galilean concept of motion. So, ayan, no? Object will move and will return to its natural state based on the object's material or composition. That is Aristotle. Anong masabi mo, Ben? Aristotle view and Galileo's view.
Yung kay Galileo, it's more scientific.
Galileo is more scientific, no?
And accurate.
And accurate, no? Yes. Yung kay Aristotle, parang vague, no? Smoke goes up in the air. Katulad niyan, composition, material, no? He's talking of object will move and will return to its natural state based on the object's material composition, no? Because
Yes.
a ball fell when thrown upward, its element was earth. Kanina, no, 'di ba, nag-thrown tayo ng ball. Katulad niyan, vague din to. Porque ba yung ball bumagsak, element na kagad air. Yung definition niya ng motion, natural motion, is largely vertical. Pag natural motion pala, vertical yan. So horizontal is not a natural motion. Huh? We do not know. We cannot make a conclusion of that. But Aristotle is talking only of a natural motion as largely vertical motion. What about the other? Ano naman matatawag mo doon? Hindi naman ba natural motion yon? Diba? Samantalang kay Galileo, in the absence of resistance, object would fall not depending on their weight but in the time of fall. Naiintindihan niya na kaagad yung vacuum nung panahon na yon, no? Naiintindihan niya na. And then if the object encountered a resistive force from a fluid equal or greater than its weight, it will slow down and reaches a uniform motion until it reaches the bottom and stops. Naiintindihan na din yung mga resistance. Halimbawa, may free falling. Naiintindihan din yung mga resistance na nanggagaling dito. O a fluid, a force, a resistive force from a fluid equal or greater than its weight. Naiintindihan na kagad ni Galileo yon. We are just talking of motion, of vertical motion. Next. Ayan naman. Horizontal motion. Ano naman sabi sa kay Aristotle?
Violent motion daw, sabi ni Aristotle.
Violent motion. Ano naman? Lahat, di ba? Any motion that required a force is a violent motion. Although, ang sabi rin niya, hindi naman daw violent yun in the sense na it is harmful or destructive physical. Pero yung paggamit pa lang niya ng term, parang inappropriate na eh. What do you think? Diba? Paggamit pa lang niya ng term, parang hindi na magtutugma sa ikine-claim niyang harmful or destructive physical eh. So ayun pa lang parang yung term niya parang nagko-contradict na, di ba? Although namin naman na hindi naman harmful or destructive physical, what is violent then? Ha? How can you define then the violent? Ha? Basta kaya ang definition niya, any motion daw that required a force, basta may force daw, any motion na may force, violent ayon sa kanya. Okay? Ayun ang kay Aristotle sa horizontal. Kay Galileo, ayun. Yung object will continue pag unimpeded, no? Pag walang umaharang, continue. Tuloy-tuloy yon. Okay? Tapos, ang object horizontal require a push or pull. Sure? Oo. Pag horizontal, plain horizontal, kailangan mo talagang mag-push or pull. Yes. I agree with that. Do you agree with that also?
Yes.
Yes, horizontal. You need to push or pull, no? To move. Yes. No? Okay. How about this one? Projectile. Okay. Ano masabi mo sa projectile ni Aristotle and Galileo?
Aristotle's projectile motion forms a letter L. Its trajectory forms a letter L. Shape.
Yes.
L shape. Trajectory.
Hindi natin nasama dito, parabolic naman yung kay Galileo, ha? Parabolic.
Parabolic.
Parabolic yon. Yung trajectory ni Galileo. Okay, projectile motion as natural and violent. Pinagsama niya na kasi nga vertical and horizontal. Projectile motion as natural and violent motion, no? Yes. Tapos heavy objects fall faster than light ones. Na-experiment ba natin ito? Ipakita natin to. Yes, ano napansin mo? Heavy object is not the basis, no? It's not the basis whether it will fall first or not. It depends upon the space where you are. Say, if you're in a vacuum, or let's say we are not in the vacuum. If the object is big, say one big object and one small object, which one will drop first? A big object and small object? Small because few resistance. Unlike the big object, there are plenty of resistance. Okay? So, something like that. Remember, sa projectile motion, hindi ko na-include dito, I did not include, but it's Galileo's that the projectile motion moves parabolic. Okay? Compared to that of Aristotle, which is parallel, and then when it is stopped, it suddenly falls, forming letter L. While Galileo, forming a semicircle or half circle. Depends how high or how low. Okay?